Girls, this is on oxidation and reduction, which is what you'd asked me to take a look at. So I'm just going to do an example one, and then I'll pick a couple out of the book that you can take a look at, and you can trial them, and then you can send me pictures of your work, and we can see where we go. Excuse Ben and Holly playing in the background, it's the only way I suppose I can get this done. So let's take a look. Here's an equation. You would be asked to balance it using oxidation reduction, or balance the equation. Once you see charges like these, you'll know that it's a balance by oxidation and reduction. Oxidation means loss of electrons, reduction means gain. So your first step, and again, if you've got your notes from last year, you pull them out, take a look. Your first step is to assign oxidation numbers across the line using your rules. So you would have been given 10 rules originally, and you're using those rules to assign the oxidation numbers. You try to do the simple ones first. So hydrogen here is clearly +1 because it's H plus. This one here is clearly +2 because again it's got a charge on that manganese. So your water, your H's and your O's are rarely going to change. So if you look across here, the other thing that's most likely going to change is your Mn and your carbons. Now the only time oxygen might change is if you were in a peroxide, but you're not in a peroxide here. So you're taking a look at this carbon and trying to figure out what its oxidation number is. So you've got a -2 because you've got an oxygen, a +1 and a +5. So that's +6 -2, so you're at +4. So that means your two carbons have to equal -4 because overall there's no charge on this atom, on this molecule. So that means your carbons are -4, which means each carbon is -2. And it's very important when they ask in the exam papers, they're going to want to know individuals, not what two carbons is worth, but what each carbon is worth. Here you've got oxygen is -2 and you've got 4 of them. So that's -8. So that leaves manganese having to be +7. Why not +8? Well, because overall the charge is -1. So +7 -1 -8 gives you -1, and therefore you're in the correct system here. If we come over here, then again, you've got +3 for the 3 hydrogens, +1 for the other hydrogen, and -2. So that's 4 -2, so you're at +2. So that means the two carbons must equal -2, which means each carbon is worth -1. So again, it's overall balanced, so -2 + 2 balances it out, and there's 2 carbons, so each carbon is worth -1. So then you look and you're trying to pick out the things that have changed. So the two things that have changed are your manganese, because your manganese went from +7 to +2. So MnO4- and it went to Mn +2. And the change was from +7 to +2. And you're trying to figure out how that change occurred. So it was +7 and it became +2. So it must have gained negative charge. So it gained electrons. So this is an example of reduction. And it gained negative charge. So electrons are negative. So it went from +7, it got more negative and it became +2. Okay. The next one then is the carbon. So you have C2H5OH and you're going to CH3CHO. Now, you've got to be careful here because you've got two carbons, but you've got to take a look at them individually. So individually, each carbon on this side was -2 and each carbon over here is -1. Okay, so there's a difference. They were -2 and then they were -1. So what's the difference here? They lost one negative. So they were more negative and they got less negative. So they lost one negative, so that's oxidation. Okay, so this one is gain, and this time you're gaining 5 electrons. And here, it's oxidation, so you're losing. Now you need to think about it. Each carbon is losing 1 electron, but in total you've got 2 carbons. So in total you're losing 2 electrons. So I'll go through it again. Each carbon is going from -2 to -1. So each carbon is being oxidized and losing an electron. In total then, you've got 2 carbons here and you've got 2 carbons here. So again, you should be able to understand this a little bit better now because that's ethanol and this is ethanal. Okay, so you've still got your 2 carbons, it's just they're rearranging themselves. So you're going from tetrahedral here and you're going into planar. You need to balance these electron charges now. So you're gaining 2 and losing 5, or gaining 5 and losing 2, that doesn't work. So I'm now trying to balance those. So I'm going to multiply this by 2 and I'm going to multiply this one by 5. So that's going to change that to 10 electrons and to 10 electrons. Okay, and you're going to put your 2's here and your 5's here. Okay, and those numbers now go back in and are fed in to the original equation. Okay, so I'm going to do that now and rewrite it here. So you're going to have your 5, and you're going to be C2H5OH plus 2, MnO4 minus, plus your H plus goes to your 5 CH3CHO plus your 2 Mn2 plus H2O. So now you've balanced the gaining and loss of electrons. Now you're trying to balance by inspection, which is the last thing. The best thing really here to do is to write down everything you've got. So on the left hand side you've got carbons, you've got hydrogens, you've got manganeses, you've got oxygens, and over here you've got carbons, you've got manganeses, you've got hydrogens, and you've got oxygens. And if I had been sensible I would have written them the right way, but I wasn't. Okay, so your carbons should already be balanced. So you have 10 here and 10 here. How do I know they're balanced? Well, that's what this was about. Okay, so if you've done that right, you should have 5 by 2 and 5 by 1, 5 by 1, that's 10. Okay. Your manganese should also be balanced. So you have 2 over here and 2 over here. Or, see, that's why I've written it in the right place. Okay. The ones you have to work with are hydrogens or oxygens. Which one to do first? Well, hydrogen is here on its own, so hydrogen goes last. And the rule normally is hydrogen goes last, in most cases. So you're trying to work out how many oxygens you've got over here. So you've got 5 by 1 there, so 5 oxygens. And 2 by 4 is 8. So 8 and 5 is 13 oxygens on the left-hand side. On the right-hand side, you have 5, and currently you just have 1. Okay, so the 5 oxygens, you're going to need 8 more, so you're going to pop an 8 here, and now 5 plus 8 is your 13 oxygens. Now you come to the hydrogens. So on this side, you've got 8 by 2 is 16, and you've got 5 by 4, which is 20. So you have 36 hydrogens on this side of the equation. On this side of the equation, at the moment, you've got 5 by 6, which is 30. So you're missing 6. So you're going to put your 6 here. 5 by 6. And where am I getting the 6 now? It's 5 plus 1. So the 6 of them multiplied by the 5, which is 30, plus the 1. And that gets you 36. Okay, that's it now balanced. So I've balanced it in terms of oxidation and reduction, and I've balanced it in terms of inspection. The only other thing they might ask you for is the oxidizing agent. Well, the thing that's reduced is the oxidizing agent, so that's the MnO4, and it carries the symbol of an oxidizing agent, which I'm not very good at drawing, as you know, but that's your symbol for oxidizing agent. So your potassium permanganate, which is the purple coloured stuff that you're used to using, that's what you're taking a look at here. This is where this feeds back in, because you may see it in a question 1 in terms of oxidation and reduction, because you do 2 titrations with potassium permanganate. The one which is the iron sulfate, and then with the iron tablet, both of them being the exact same titration, really, just in different formats. So you may see this a little bit more. So what I'd suggest now, girls, is that you go and take a look at your textbook, and that you try a couple. So I gave you loads this time kind of last year, but it's up to you now to try and pull a few more. So balancing redox reactions, so it's on page, it's saying here 206, and you might find more of them again. And there's ones here now with samples in the book. He does them the exact same way I do, so you shouldn't have an issue. But the good questions here would be at the end, so it's page 211. So I'm going to write it down here, so I'll put a post up, page 211, and if you try question 14.8, and they're balancing by redox reactions. The only thing you have to remember when you're using oxidation reduction and oxidation numbers is they don't have to make sense. So you can have 2.5 as an oxidation number, even though we know you can't gain or lose a half an electron. But this is a man-made system, so that makes it a little bit, excuse me, it's not coronavirus, you don't need to worry about me, it's talking too much. You can have 2.5, you can have 3.5. So just to be wary of that. So what I'd say to you girls is I'm going to put this post up now. Well, I'll probably put it up today just because I've done the video, but it's not due because you were not in school Monday, Tuesday. So this would be Wednesday's work. So we'd say we take a look at it on Thursday. So if you can post a picture of your work, if you're interested in doing it. Now, if you already know how to balance oxidation and reduction, this is not work you have to do. But I know, for example, Nicolette, I think you in particular were looking at oxidation reduction reactions. I'd ask you to take a picture of yours, one's balanced, and I'll have a look and see what mistakes you might be making. Even if you do maybe the first 3, get me to check them before you move on. The answers are all in the back of the book, so you can check them that way as well. But if you want to check with me first before you do maybe more than 3, because you don't want to do a huge number and then realise you're wrong. So I'll leave it at that, girls, and that's taking a look at oxidation and reduction for you. And then I will come back on here before Wednesday, and I'll take a look at that 2015 and 2014 paper and doing that question 1, the new method, even though they asked it the old method. Best of luck and talk to you soon. Take care.